is adding and subtracting. So what we've done already was the multiplying and dividing. The first step, 1 and 2, are the same. Okay, so step 1, factor. Step 2, state restriction. So same steps as we did before. When we multiply, divide, add, or subtract, we are still going to always factor state restrictions. Any type of factoring goes, right? So we can do any type there. Then we're going to find the lowest common denominator. So the lowest common denominator is when we do fractions. So when we're adding and subtracting, so I'm going to remind you of that. So when you had 1 over, say, 6 plus 1 over 2, what's the lowest common denominator between a 6 and a 2? 6, right? So then we go and I multiply this one by 3 on the top and the bottom so that they're both 6. Now, when I do this, looking at this, I would say, okay, can I write it slower and pretend I was trying to teach a younger person? I said, this is the same thing as I'm going to do 1 plus 3 times 1, and they're both over 6 now. They both have the same slices. So then we do this and we get the 4 over 6. And then do we try to reduce at the end? Yeah, we try to reduce at the end. So we go, okay, at the end, if you can reduce, then you do reduce. Make sure you do an arrow, and then you go 2 over 3. Okay, so that is lowest common. So we do lowest common. It doesn't mean we just multiply each other by that by 6 and that by 2, because that wouldn't be lowest. So L stands for the lowest common denominator. Lowest, okay? Then we can slow it down a bit. So lowest common denominator, okay? Denominator. Okay, but we're looking for lowest. So here you would not do 12 because that wouldn't be the lowest, and that means that you'd have to reduce more at the end. We go, okay, between the 6 and the 2. So when you look at this, you go, okay, that's a 6 and that's a 2. What you're actually doing is you're breaking it down to factors. You didn't know you were doing it, but we were. 2 times 3, 6 is actually 2 times 3, right? So you're breaking it down to the factors. I know that 6 is actually 2 times 3. So you had one of the factors, 2, but you needed the other factor, 3. So what you were doing naturally when you're looking for the lowest common denominator is that you were breaking it to the factors and trying to make them the same factors on the bottom. So that's the idea we have here. We want the same factors on the bottom so that they match. Here, look at the first one, they already are the same factors. So if I said to you, here, and I go add and subtract the numerators, like we go 1 plus the 3, keep the 6, and then factor and cancel more, which means simplify more if you can, right? So we've been doing this with numbers, and now we're going to do it with polynomials, all right? So we would add them, keep the denominator, and then simplify again if possible. So that was our method. So we're going to do the same thing here. We look and say, okay, these two here, they already have the same denominator. So if I said to you, if I said 1 over 3 plus 2 over 3, do I need lowest common denominator? No. I would add the tops, right? Keep the 3. You usually skip that step and just go 3 over 3, but that's just because you're cool. I'm just kidding. You would do that just because you add them in your head. Here with polynomials, you kind of have to show the middle step because adding all those variables is hard to do in your head. Okay, so we're going to show the middle step. So normally you would go 1 plus 2 and go to here, but with polynomials we want to show the adding, okay, because it's too much to do in your head. Okay, so here we have the same denominator. I don't need the lowest, it already is the lowest. Does that make sense? We're going to highlight. Is there any factoring I can do? Can I factor the top? No. Can I factor the bottom? Top, bottom? Nothing. So I can't factor, so step 1 is already done. Step 2 is state restrictions. Restrictions are always restricting the denominator. We know that from before. We are always going to restrict the denominator. Okay? So this x minus 2 is restricted. So then we're going to say over here, and again, you can drag it to the side. I try to do it neatly just so you can read my notes, but I'm going to drag a little line over here for my rough, and I'm going to go x minus 2 cannot equal 0. Okay, x minus 2 cannot equal 0. You can do that faster if you're comfortable. X cannot equal 2. So I already have that one restriction. Do I have to state it twice? No, right? You already have it once. Don't state it twice. You're good to go. So you got the once. Now, what we did here was we added the tops, or subtract the tops, whichever, and kept the bottom. We're going to do the same thing here. If they already have the same denominator is there. Then we're going to do this. We're going to keep the denominator, so just like what we did here. They're both keeping the same denominator. And we're going to subtract the tops, or add whichever the operation is. So here, I'm going to go 2x minus x plus 4. And I want to minus both of them. Like that's for both of them. So you got to put a bracket, or you got to distribute the negative. I want to subtract both of the terms there. So this is why I'm saying now here when we're doing polynomials, we're going to show this step because it's too much to do in your head, right? So having to do 2x minus x all in your head is a lot of work, especially when the questions get longer. So we show the middle step. When you were doing fractions before, you just added it or subtracted it and went to the next step. Polynomials is too hard to do that. Okay, so we're doing, I'm subtracting the tops, keeping the bottom. So keep, oops, P. So keep denominator. Okay, subtract the tops, keep the denominator. Does that make sense? So keep it. People always go, do I need it twice? No, we're not multiplying. We're not multiplying. Look, we're just keeping the denominator. We're not multiplying. We keep the denominator, add or subtract the tops. Okay, and now we're going to keep going. Bring the negative in. Put your line here. See how I'm lining up in my equal sign? Right, so line it up there, please. Okay, don't miss it too much, right? Because otherwise your equal starts to float way high or way low. I do this, and that always makes that's why you go, wait, it always looks more symmetrical, because I do the line first. And then I go 2x minus x minus 4. Right, brought the negative in. And then, can I do more? 2x minus x are like terms. So 2x minus x is x minus 4, right, like terms. X minus 2. And now I have a binomial and a binomial. Can I cancel those binomials? Nope, they're not the same. You have to do the whole binomial or not. Those two are not matching. So then I do nothing. I'm done. That's my beautiful, gorgeous, gorgeous answer. So I stop there. Right, you have to know where to stop. And then you go, x cannot equal 2. Yes?
So for this, you couldn't simplify the 4 over 2?
No, because the minus, it's a binomial. So monomials are joined with multiplication. So if I had given you this, if I gave you this, that's multiplication. So that guy, we can go, okay, break that off. 2, the x is canceled to be 1. But as soon as I do this plus, it makes it a binomial. And it's either the whole binomial or not. You have to grab the whole binomial. Or if it's a trinomial, the whole trinomial or not. Yeah. So that's a very, very key, right? We've gone over that before. This is really important because it's the visual. They look very, very close. And this is a common mistake. We wanted to stop this. So this one's a very, very important concept. When it's multiplication, when it's a monomial, you can cancel. When it's a binomial with a plus or minus between, you can't do it unless you take the whole thing. Okay, so it's very big, the difference between. Yes?
How'd you get rid of the 2x?
The 2x minus the x. So like terms, 2x minus the x, so 2 minus 1. Yeah, that made a 1x. Okay, so talk to yourself and say, I have a binomial with a binomial. I can only cancel the whole binomial with the whole. It's not this, right? This is always a big concept. You got to get through this one and this one, the difference between them. Okay? Okay, good. Another question? All right, so let's try it again. And we're just going to keep changing the denominator and what we have to do to make it the lowest common denominator. So here, we have addition. So you go, okay, these are addition subtraction questions, right? So these are addition subtractions. Make sure you state restrictions on the variables. We usually remind you, but anytime you get a denominator, you should state it no matter what, right? You're always stating it. Okay, so then let's try this again. Factor first. Step 1 is factor. Can I factor anything? Nothing, right? Okay, so I can't factor anything here, top, bottom, nothing, nothing. So then restrictions. Restrictions are from the denominator. Can you restrict to 6? No variable. Can you restrict to 4? No variable. So no restriction. So on the side here, I'm going to write to myself, I did check it, right? And for myself, I make a note, no restriction. Okay, so I know that, and I'm going to be like, okay, I checked already, no restrictions. Otherwise, I'm like, wait, did I check? I did. No restrictions because there's no variables on the bottom. Now we're going to do lowest common. So step 3 now is lowest common. So look at the denominators. Between 6 and 4, what is the lowest common? 12, yes. So 12, both of them can become 12. So this one, I need a times 2 on the top and the bottom. I do a bracket, not a times, because the times looks like my x. And then I'm so confused. I'm like, is that an x or times? So you can put a bracket. You can put a time sign if you want. You don't even have to show that. I'm just showing you my thought process. So here, I want to do 3, right? So times 3 to get them both to 12. Yes?
No, I was going to say, I think the other class is only allowed to use like dots for the multiply, so it doesn't get confusing.
Yeah, bracket dot, yeah. I don't love dots just because I don't see them very well. So, yeah. Okay, dots, brackets, doesn't matter. But yeah, you can technically use the time sign. It's just, it's not, you should put in a bracket, yeah. And it looks the same. And also, yeah, you should put the bracket there just to remind yourself. But yeah, most teachers are like, try not to use the x. It's so confusing because then if I put a monomial there, you don't know which one's an x and which one isn't. And you just like, yeah, so it's bad. So try not to. I like brackets, yeah. Okay, so just, yeah, that's always a recommendation is that try not to use an x. It's so confusing. All right, so here, now I'm going to rewrite it. I'd like to rewrite it. You don't have to write that line. I sometimes find setting it up because then I check 12 and 12. We're good. And we're going to go equals. Okay, and I put a line. I'm going to bring them together. So now they're both sitting on 12. So once you've decided on the lowest common, I say they're both sitting on the 12. Right, good to go there. And then here, x plus 3 with the 2. So I write that again. You can start to distribute. Again, don't skip steps unless you're sure you're not going to, lose a sign and stuff. So I like to write this step. So 2 times x plus 3. And then I take the sign here in the middle. So watch out. My sign in the middle, I'm going to grab it. That goes here plus. So it's still plus. Right, it doesn't become all multiplication. I'm adding the 2 fractions, so adding it, plus. And then I like to put my monomial in front. Again, I just like distributing it from left to right, but you can put it after or in front. I always put my monomials in front to clean up. Okay, so then I write that again. Some people go right ahead into multiply. Don't skip too many steps, though, because, again, you're going to do too much in your head and lose a sign. Okay, so here, if you skip that step and went to 2x plus 6, and then look what I'm doing, 1, 2, 1, 2, and then showed me 6x minus 9, that's okay, right? So if you skip this step and went to here, I can still follow, but don't skip more than that, just I can't follow what you're saying. Remember, you're trying to tell a story as you're doing the question. I should be able to read from the beginning, oh, cool, then you did that, oh, neat, oh, wonderful, and that's, so I'm following from beginning to end. Okay, so at most you could go to here instead of that. I prefer you showing me that, though, right? I still like that step. But if you do that, that's okay. 12, no more. Don't skip more than that. And then now we're doing like terms. So 2x and the 6x is 8x. And 6 minus 9, so negative 3 over 12. Okay? And now we have a binomial on a monomial. We can't cancel those guys out. One's a binomial, one's a people are like, oh, can I cancel? Nope, nope. Binomial with a monomial, we don't cancel unless we're going to cancel the whole thing with the 12, get 12 into both of them, then we don't. If we can cancel both, that's okay, but we can't. Okay? So then I go, comma, don't leave it with no restriction. You're going to state no restrictions. You have to say this, not just leave it blank. If you leave it blank, I'm assuming you just didn't get to the question, like you didn't finish it. Okay? Let's try again. It's just understanding how to do the lowest common. So here. Between these two, that's a binomial x minus 1, that's a binomial x plus 2. I think of this like if I gave you 1 over 4 plus 1 over 3. Totally different factors, right? There's nothing that's common about them. One's a 4, one's a 3, just like here. X minus 1, x plus 2. Totally different factors. So if you had something like this, I would say that the lowest common denominator would be 12. So then this would be multiplied by 3, and this one's by 4. Right? So you're multiplying, this one's 4, 3, 4, 3, 4, then they're the same. So same idea here. If they're totally different factors, you're going to say, okay, these are totally different. So here they were the same. So you just had to add or subtract the top. Here they're different. So we're going to multiply this one by x plus 2 and x plus 2. So I'm going to write it on this side, actually. I have no room. Okay, and this one by x minus 1. Okay, so now both of the bottoms, right, look at the denominators. It's an x plus 2 and an x minus 1. This is an x plus 2 and an x minus 1. So now both of the denominators are the same. Right, so just like this. If they're not the same factors, you multiply this one by that factor and this one by that factor, and you'll get the lowest common. Does that make sense? Okay. Oh, my first step was to factor, but there was nothing to factor, right? So the next ones I'll add factoring more to it. Yeah.
You'll always do that?
Yeah, I can always do that if they're different, yes.
Okay.
Yeah.
It'll always be right.
Yeah, it'll always be, if they're different factors, I multiply this factor by that one and this factor by that one. And I'm going to keep showing you more. So sometimes there'll be one the same, one different, two the same. Yeah, so then we'll see how we match it. So do you like how they're both the same bottoms now, though? So look, that denominator, x plus 2, x minus 1. This denominator, x plus 2, x minus 1. I want the denominators to match. Because then I go like this. What's the denominator now for both of them? The same denominator is x plus 2, x minus 1. Matching, yes? Same, same, and I wrote it down here. Okay, so I want them matching, and I write it down one time, just one, not squared. We're not multiplying. We're not multiplying. People are like, 2 of them? No, we're not, we're adding. So just like what we did here, right? So again, when you do it with numbers, it's easier. So look, made them both 6, and I went 1 plus 3 over 6. I didn't make that denominator 12, right? They're both sitting over 6. So we're not squaring the denominator. We're saying they're both sitting on the same denominator. So not squared. We're not multiplying it. We're saying they're both sitting on the same denominator. Yes?
So you're not like foiling x plus 2 x minus 1?
No, do not FOIL, don't expand. I like the factored form. The factored form in the denominator is better because I know what my asymptotes are going to be, or my wholes, right? Because the factored form is where we start to cancel. So always leave it factored. So we're going to say leave it factored. Factored is glorious, gorgeous, gorgeous. We always leave the bottom factored. Yes, yeah.
So what you wrote up the top there, like the x plus 2 and then the x minus 1 on the other side,
Yep.
are you not multiplying those into the things on by the denominators?
So the denominator, that was just what's asked. Yes, good. So I want the denominator. So this is my new denominator, which is matching this one. They're both sitting on the same, I want that factored form. Yeah, we
so
want
you don't multiply that.
Don't multiply it out. Do not FOIL it out. Do you know why? Because those are my wholes and asymptotes that we learned in 2.5. And it's beautiful and gorgeous to factor, solve. I can graph it. There's so much you can do. Factored form has so many possibilities. Don't unfactor it. Okay, so never unfactor. That's a very good point. Okay, so never unfactor my denominators. They're gorgeous that way. Beautiful. If you unfactor it, you're doing more work. I can't see where the asymptote and holes are. Right? Where am I supposed to look? Where are they? Then I have to factor it. So you're doubling your work. So leave that bottom factored form. Good, good. So the top, what I did was, so look, I have x times x plus 2, and I'm still going to add it. So this is still addition, right? We're still adding it. So now we're setting it up to this one, 3x, x minus 1. So just like what I did here on B, right? So right here, I had 2 times that bracket plus 3 times that bracket. I was finishing the top, keeping the denominator. We're not squaring that denominator. We're going to leave it. So they're both on that denominator. So here I have x times that plus, that still goes between them, 3x times that. Okay, so it's still 2 terms that we're adding together. 2 rational functions here, 2 of them, 2 rational expressions right there, here and here. We're adding them together. We're doing the top of this one and the top of that one. We've got the plus in between. And now they're both sitting on the same denominator. Both sharing that same denominator. Once they're the same, you're basically saying, can we just share that denominator? We're not multiplying it. We're just saying we're all the same. We're all sitting on the same denominator. Then you're going to keep going and go 1, 2, 1, 2, right? Expand that. And then we're going to finish it off. So we're going to go like this. So equals, keep the denominator. Factored form is glorious, glorious, gorgeous, gorgeous. Leave it there. And we're going to bring the x in. So we go x squared, x times that, 2x. 3x times x, so plus 3x times that. So it's plus 3x squared. And plus 3x times that, minus 3x. Okay, and then we're going to finish that off. Are there any like terms on the top that I can gather up? Yes, yes, and then this one with this one. Right, so we're going to do this. Keep the denominator in factored form. Why? Because it's beautiful. Okay, on the top, x squared plus 3x squared, 4x squared. 2x, positive 2x, minus 3x, minus x. Okay. Oh, I didn't do my restrictions at the beginning. I got so excited about the lowest common. Did I cancel anything, though? No, so it's okay. I didn't cancel anything, so I can do my restrictions now. Okay. Also, can I simplify that anymore? Yeah, what can I do? Yes, beautiful. We always want to fully factor our answer because it's so much nicer that way. So if we can fully factor one more time, we can take out the x from the top, and we've got 4x minus 1. There we go. Now it's all factored. Can I cancel anything else? Nothing to cancel. No, all good, all good. And my restrictions, which I forgot to do, but I can do now, and I didn't cancel anything, so I'm okay. Right? If you canceled something, you got to make sure you don't cancel it out. So let's go back. The denominators are x plus 2, x minus 1. It's the same here. It's still the same the whole way through. So we're going to do x plus 2 cannot equal 0. Okay, and again, you can go faster or slower on this. You can show it, or you can write x cannot equal 1. So we have our 2. And then that would be x cannot equal, I'll write here, x cannot equal negative 2 or 1. You can write it below. If you run out of room there, just put comma and then write it below. So it cannot equal negative 2 or 1, and we're all done. Okay, I think I'm going to pause here.